Okay, we continue with part 2 of April 2021. There's certain questions, as I explained to my class here. Certain questions, like question 3, we can always get back to Newton's method and finding the turning points. It's a bit too simple for me to go and do it now. So I want to deal with the most important stuff first, which will be question 4, the integration. Now, you're coming very close to that final exam. So let's have a look at how how question 4 is stated now. It says determine the integral of y dx, and then you're given y. Now, most of you, I see when you're answering your question, you know the integration. The problem is you are not setting up the problem properly, because normally in N4 or in some exam papers, it's just given to you like this. Yeah, the integral of maybe x squared dx. So you already have your integration symbol, you already have dx there. Now, the question is given to you, y is equal to. Now, it's a simple thing to do. All you do is, when you are answering the question, okay, you will not write down y. The question states, determine the integral of y dx. So when you write down 4.1.1 in your exam booklet, you're going to put in your integration symbol there, and then you're going to replace y with whatever you have here. So which is 4 times my 1 over x minus e to the power minus x. And you've got cos e to the power minus x plus an x dx. Okay, so this is what will be seen, what the marker is going to be seen in your answer booklet. Okay, we don't need to go and see y over there. Y was given to you on the question paper. So now we know this is an integration problem. So now let's focus on the integration. So you should know now, if you're my student, you know your exact derivatives in your head. Okay, you do not need the formula sheet for exact derivatives. So the first thing that you are looking for any integration problem, the first thing that comes to your mind, do I see exact derivatives here? Yes, I can see it. Look at this here. The derivative of ln x is 1 over x. The derivative of e to the power minus x is e to the power minus x times minus 1. So you know that this can be done. If there's exact derivative, there's two methods. One is by inspection, and the other one is by U-substitution. So what are we dealing with here? Let me just write that down. So let's deal with this first by inspection and then by U-substitution. So now, by inspection, we are dealing with a situation where you have cos of f of x. Okay, you're integrating, you got cos of your function of x multiplied by the exact derivative there. So that is f prime x. So now, if this is the situation, okay, then if you remember something like this here, k cos, let's just say k, let me just put it as cos of x, straight. Let's go back to our N4 work. Because once you understand it properly, then you'll be quick in working this out. So now, this is cos of x. Let me make it times 1 there. I don't have to write down that 1. But basically, the derivative of x here is 1. Now, what did you differentiate in order to get an answer of cos x? Okay, it was sine. That means when you integrate cos, the answer is going to be sine x plus c, and you're done. Okay, so if it was the integral of, let's say, cos 3x dx, let's put it as times 3 also. Now, what did you differentiate that gave you an answer of cos 3x times 3? What did you differentiate? You differentiated sine 3x. And then you're done. Plus c. If you differentiate sine 3x, the derivative of sine 3x is cos 3x times the derivative of 3x, which is 3. This is understanding our differentiation. Okay, so now you are used to doing it in N4. If I gave you the question, let me just redo that just to make sure. Then if you're applying the formula, that means it's going to be integrating cos 3x is going to be sine 3x all divided by 3. Can you see that? This is using the formula. When you integrate cos bx is going to be sine bx all over b. What happens here? 3 and 3 cancel, so you end up with just sine 3x plus c. So it depends on how you're thinking. See, are you going straight with using the formula, or do you know your differentiation? And then you can get the answer in one step. Now, in N5, that is how we did it in N4. In N5, you must understand f of x, f prime x for every single example. That's what you're checking for. So if you have a situation k cos f of x times f prime x, we know that the answer is going to be sine f of x plus c. Because remember your differentiation. When you differentiate sine f of x, the derivative of sine f of x is cos f of x times the derivative of f of x, which is f prime x. Okay. So if we have a perfect situation like this, this is a perfect situation. Look at it. You got cos of f of x. Let's see if this is an exact derivative. The derivative of e to the power minus x is e to the power minus x times minus 1. Plus the derivative of ln x is 1 over x. So that means the answer is straight for sine of f of x. K sine of f of x. So that's sine of e to the power minus x plus ln x plus c. Okay, so that's it. That's by inspection. Okay, and here is the formula. If you want to write this down, if you're using it, I think it's best to write down the formula that you use. That is inspection. So whoever's marking your paper understands that this can be done by inspection also. See? Now, alright, so now let's go to a more understandable, more popular method, which is U-substitution. So let's redo this example. So we got 4 times 1 over x minus e to the power minus x cos of e to the power minus x plus ln x dx. Okay, so now most of you prefer to do U substitution. Okay. Now if you see exact derivatives, there's nothing stopping you from doing U substitution. It's fine in N5 level. You have time. Okay, it's not like you're not going to finish the paper if you use U substitution. But in N6, it's going to be a problem for you. Alright, so it's best to learn both methods properly now. So with U substitution, we know that if you have the situation f of x, f prime x, then you always let u equal to f of x. You always do that. Okay, so in this case, it's cos f of x. Don't get confused now because this is how it's written. It doesn't matter, it's multiplication here. It doesn't matter if the f prime x is written here or written there. It is multiplication, so it's still correct. Now, you let u equal to f of x. There's my f of x here, which is e to the power minus x plus ln x. Now here you'll be able to see everything cancelling. So this is my u, du over dx. The derivative of e to the power minus x is e to the power minus x times the derivative of minus x, which is minus 1, plus the derivative of ln x, which is 1 over x. So that's my du over dx. Now I need to make dx the subject of the formula, so du is going to equal to, I got my minus e to the power minus x plus 1 over x times dx. Make dx the subject, so that's going to be du all divided by minus e to the power minus x plus 1 over x dx. So that's our U substitution. Now you can see what cancels. So This is equal to 4 times the integral. I got my 1 over x minus e to the power minus x. Then I have cos of f of x. Now it's cos of f of x, but what is my f of x? It's now replaced with u. You can see that. What happens here? Dx is equal to du all divided by minus e to the power minus x plus 1 over x. Now you can see that these two are the same. It's just that this term is written first and that is second. But the fact is, they are identical. So they will cancel. Now you can see that it cancels. So what remains is just cos of u. And now when you integrate cos of u, that's going to be sine of u plus c. Why? Because when you differentiate sine, you get a positive cos. So that's why when you integrate cos, you get a positive sign. It must work backwards. Substitute back for u. What was u? U was e to the power minus x plus ln x plus c. And there's a chance this is more understandable for the majority of the people. Okay. If you want more in-depth knowledge on integration, then you need to learn it this way also, where you can work it out in your head before you write it down. Okay, that's very important. You must be able to see it in your mind before you put it on paper, especially when you come to the next level. And then when you come to N6, you'll notice that there's no time for doing U-substitution all the time. You will not finish the exam if you carry on doing U-substitution all the time. But in N5, it's fine. Okay, and if you're very fast, it's also fine. All depends on your speed. Right, so 4.1.2, I just transferred it as I'm answering the question in the exam. As if I'm going to answer in the exam, so I didn't write down y there. Remember, you put your integration symbol, your dx, and you just transfer what you have there. Now, how do we integrate something like this? So this is a fraction. There's a square root in the denominator. Now what's inside of the square roots? 4 minus 9x squared. First thing you check for, just as I explained the previous example, the first thing you check for is, do you see an exact derivative anywhere? Right. If this is an x squared here, do you see an x on the top? Okay, that's the first thing that you check for. What happens if it was an x on the top? So you must be able to distinguish between the different x's. You can see they don't tell you what method to use here. You must have done thousands of examples for you to just look in 2 seconds and just know that I need to use inverse sine. So be careful. Let me just write this down, yeah? So be careful. If you had a question with x on the top, if there was an x there, it's a completely different problem. Completely different problem. So what do I mean? If it was a situation like this, then we are dealing with exact derivatives, which is f of x to the power n times f prime x dx. So you must know that if there was an exact derivative, this is the way you're going to be dealing with it. So this is the first type that we dealt with in N5, where your n must not equal to minus 1. So what do I mean? I'm just going to show you this by inspection quickly, so you don't make a mistake when you look at that example. So here, this is multiplication, f of x multiplied by f prime x. So I'm going to take this to the top first, 4 minus 9x squared, all raised to the power minus half. Obviously, you know when you take the base to the top, the sign of the exponent will change. And then you have your x dx. Now I'm going to show you an inspection. Okay, just to make sure that you're clear with what's happening. So there's my f of x, 4 minus 9x squared. F prime x, the exact derivative of minus 9x squared is supposed to be minus 18x. Can you see that? So there was no minus 18, it was just a 1. So this 1 is the same as minus 18 all divided by minus 18. Once you understand that simple trick, then integration becomes easy. So if I put a minus 18, I must divide by minus 18. There's my minus 18 over minus 18. Can you see that? Obviously, you have to put a 1 there because this is a fraction. So what did I just do? I got my k now with my constant in front there. So the answer is going to be minus 1 over 18 f of x, which is 4 minus 9x squared, n plus 1 minus half plus 1, that's plus 2 over 2, so 2 minus 1 is going to be 1 over 2, all divided by 1 over 2, plus c. You can simplify this further. I'm not interested in that at the moment. Okay. The main thing I'm interested in is, did you realize that this is the way only if you have an exact derivative. Now let's shift our focus to our problem here. There is no exact derivative here. So you cannot do it this way. This involves U-substitution. So or inspection. So remember that was U-substitution or inspection here. But U-substitution fails, so we use a method called trigonometric substitution. Right. We use sine substitution, we use tan substitution, and a sec substitution, which I showed you. But this is only 3 marks. That they did not state use a trig substitution. So therefore, you can apply the relevant formula. Remember this. Now, in the N5 formula sheets, this is the relevant formula. You got 1 over the square root of a squared minus x squared dx. There's no b here. Okay, there is no b. So do not confuse this with the formula like how it's given to you in N6. Some of you are familiar with it. Okay. So this is how it's given in N5, and then the answer is just going to be inverse sine x over a plus c, and you're done. Okay. So now we've got a problem here. Okay. That's a formula, but what we have here is not a perfect match. I'm talking about the constants. Okay. So you cannot go and just apply the formula. There is something missing. Right, now let's go and try and rewrite it as perfect squares. So I got my a squared, so this is going to be 2 squared. Right. Then I got x squared here, so I need to rewrite this whole thing here. This is going to be 3x all squared. Okay. Now, with the problem here in N5 is that we do not have the coefficient of x squared is always a 1 here. Can you see that? So in our problem, it was not a 1. It was a 9. So it was 9x squared. So what a simple thing to do here is, let u equal to 3x. Right. So now du over dx, the derivative of 3x here is 3. So then make dx the subject of the formula. So that's going to be du divided by 3. Okay. So we do a substitution. And that's going to be 1 over the square root of 2 squared minus 3x is no more 3x. Now you can see that. 3x is no more 3x. It is u, so that's u squared. Dx is going to be du over 3. So what do I have? I have 1 over 3. And then I got the square root of 2 squared minus u squared du. Now, it's in standard form according to the formula sheets. So now we have a value for a. Wherever I see a, I'm going to put 2. And you have a value for x. There's no more x now. It's replaced with u. Right. So there's the answer. It's going to be 1 over 3 which 1 over 3 was already here. You can see that. So that's my 1 over 3 times inverse sine x over a, but now x has been replaced. Yeah, this is how you do it. It's going to be u over a, which is 2 plus c, and you're done now. So that's 1 over 3 inverse sine. My u is 3x, so that's 3x over 2 plus c, and I'm done. Now before you copy this down, let me just show you how it's given to you in N6. If you want to try and avoid the U-substitution technique, then there's one thing you need to memorize. Yeah. Let me just write it down here. So in the N6 formula sheets, you do not have to go and do it the long way, like I said. So it's given to you as the square root of a squared minus b squared x squared. Right. So the only difference now, there's the N5 formula sheet, there's the N6 formula sheet. So that's going to be 1 over b times inverse sine bx over a plus c in one step. Watch this here. So let's take the question. I got the square root of, the original question was 4 minus 9x squared. So that's going to be 2 squared minus 3 squared times x squared. Can you see the difference in the way I'm representing this information? Here, I put 3x inside the bracket. Can you see that? Here, it's 3 squared times x squared. Now, it's much easier in the N6 formula sheet, or if you've got a good memory, you memorize this here. Then you've got no problem with the exam. Okay. This is just one of 6 formulas, okay, for inverse trig functions. So look at this. In one step, 1 over b. b is here. So what's your b? 3. One time. You can see that. So that's 1 over 3 times inverse sine bx over a. So that's going to be 3x over 2 plus c. So this is in one step. This takes a bit longer, but nothing difficult, right? There's nothing difficult with using a U substitution. There is another way where you can take out a, let me just show you one time before we move on to the next example. So there's another way to deal with this here. Right, so let's have a look at the third way to deal with this. So going back to N5. So I got 1 all divided by the square root of, what was it? 4 minus 9x squared dx. Right. So this is way number 3 where we avoid, so this, it's either you want to try and memorize it like this where you can do it in one step. The only difference between the N5 and the N6 formula sheets, in the N6 they always have these values be. Okay, now let's go back to our N5 work. So I can try and take out a common factor here. So what do I mean? I have 4 minus 9x squared. Right, that's what I have. The coefficient of x squared is always 1 in your N5 formulas for trig substitution. So, if I want the coefficient of x squared to be 1 here, or minus 1 if you look at it, then you need to take out a common factor. If I take out 9, that means I'm left with minus x squared here, because 9 times minus x squared is minus 9x squared. The question is, what will the first term be? If I took out 9 times minus x squared is minus 9x squared. So this will be 4 over 9. All you do is you take the number and you divide by what it is. Check now. 9 times 4 over 9, 9 and 9 cancel, you end up with 4. Now, let's do it here. So this is 1 divided by the square root of 9, and that's 4 over 9 minus x squared. There's my dx. Now I can go one step further. So if I have the square root of 25 times x squared, we're going back to high school now, we're dealing with some exponent laws. Right, so if I have a square root here, this can be splitted up. I can write it as, let me put times z squared times k squared also. Okay, I can split this up. I can write it as a square root of 25 times the square root of x squared times the square root of z squared times the square root of k squared. If it's multiplication, I can do this here. Okay, so this is going to be 5 times here. This will be, I'm taking only positive values here. We know there's two possibilities, but I'm just going positive there, there, there. What's the point to all this here? The point is that I can split this up here, and I can write it as the square root of 9 times the square root of 4 over 9 minus x squared. Now, I split it up using my exponent laws, and now I can find the square root of 9 there, which is 3. And now, finally, I have it in standard form. 4 over 9 is the same as 2 over 3 all squared. Why? Because 2 squared is 4, 3 squared is 9. You can see that. Minus my x squared. There's my dx. So now what have I done? Okay, I have now rewritten this in standard form. The whole idea here was for this number here to be a 1 in front, because in the N5 formula sheet, that's how it's given to you. Now, you got your 1 over 3. Well, that's part of the problem. There's your 1 over 3 times inverse sine. I'm using the N5 formula sheet. There's it here. Inverse sine x over a. There's my x here. So that's x divided by 2 over 3. Let's see. I'm done. All I need to do is just simplify that last part. So this is going to be 1 over 3 times inverse sine. You know, when you're dividing by a fraction, invert and multiply. So that's going to be 3 times x, or 3 over 2 times x, and you're done there. So that's 3 different ways, okay, to deal with this problem. It's up to you. It's your choice. It's only 3 marks, and it's not that difficult. Right, 4.1.3, we have a fraction. Okay, we have a fraction. First thing to check for, you can see there's a quadratic here. This is a quadratic. Can it be factorized? But that's not so important if it can. Can it be factorized, and is one of the factors x minus 3? Will it cancel? That's the first thing that you should be thinking. Okay. If I try and factorize this, will it cancel with x minus 3? So how do you check? How do you check now? That's why you have to know your factor and remainder theorem properly. If I want to check if x minus 3 is a factor, that means if I substitute 3 here into the top, I should expect a remainder of what? Of 0. That's all. On your calculator, it only takes 3 seconds. It depends on how fast you can type. If you want to check if x minus 3 is a factor, you will substitute 3, because 3 minus 3 will give you 0, obviously. You substitute 3 here, and do you get a remainder of 0? What is the answer? Yes or no? Do we get 0? No. That means it's not that simple. Okay, maybe in N4. In an N4 paper, they will give you something where you can factorize, where you can cancel. Right, but now this is N5. It cannot be factorized. So, what do? We notice this is a fraction where the numerator is of a higher degree than the denominator. What does that mean? It means the highest power of x in the numerator is greater than the highest power of x in the denominator. So if they are equal, or if the top is greater than the bottom, then you must use long division first, or there is the U-substitution. Alright, but let's do long division first. Now, let's deal with our long division. Right, so you know, you would have done many examples on long division. Your denominator is called the divisor. You don't have to worry about what it's called. The main thing is you know how to do it. But basically, the denominator is now called the divisor. The numerator is called the dividend, which is 2x squared minus 5x minus 1. The answer will be the quotient. Right, so long division, 4 steps. DMSB, you should be competent with this by now. Okay, so we're going to divide, multiply, subtract, bring down. Right, so divide. I'm going to go 2x squared divided by x. So I'm going 2x squared divided by x, and the result directly above. So what is the result of 2x squared divided by x? It's just 2x. So that's done. Multiply. What do you multiply? You multiply the results that you just worked out by the entire denominator, the entire divide, not only by x, by all terms. So now, what am I doing? I'm going 2x multiplied by x minus 3. So 2x times x will be 2x squared. 2x times minus 3 is minus 6x. I'm done with that. The next step is subtract, top minus bottom. So, top minus bottom. So all you do is you change the sign of the bottom term and you work it out. So if this is a plus, I'm using a different color so you can see. This is originally a plus, change it to minus. Originally a minus, change it to plus. Nothing difficult, very simple. Okay, so that minus that, 0. First term must always be 0. If you do not get a 0 here, that means you made a mistake somewhere. Right. The x's down, minus 5 plus 6 is a positive 1x. So we're done with subtract. Okay. If you're having a problem subtracting, then you take this whole thing and write it down horizontally. I did show you that before. If you're not clear with changing signs and all that, you write down this whole thing minus the bottom. The next step is bring down. So I'm bringing down my minus 1. Now, is it possible to do, remember, bring down, so that was the 4 steps done there. Now, is it possible to divide again? How do you check if it's possible? Right, so I'm saying, is it possible? How do you actually do it? So now, you forget about everything that happened here. This was the original question. This is your new question now. Okay, there's your x minus 1. This is your new problem. So now you're going for the 4 steps again. So you're going to go, there's your divisor. Now, so that's x divided by x. This is what you are doing, divide. Just like how I went 2x squared divided by x, now you're going x divided by x. If these are equal, or if the top is equal or larger, then you divide, you continue dividing. Okay, like now, it's equal, obviously I can cancel x and x will give me 1. Right, so now, what do I have? X divided by x is positive 1. Multiply only the one that you just worked out now. So I'm going to go 1 times x, which is x. 1 times minus 3. Minus 3. It's just a simple process. Okay, and so now, change the sign of the bottom term. I divided. For the second time, multiplied. For the second time, I need to subtract for the second time. And what should I expect for the first subtraction? It must always be like, look here, 2x squared minus 2x squared, 0. 1x minus 1x, 0. Minus 1 plus 3. You can see how I'm changing the sign of the bottom term. Minus 1 plus 3 is a 2. If you don't get these zeros, you know there's something completely wrong that you did there. Right. Now we done. Now we check. Is it possible to divide again now? That is the question. So what do I have? 2. You do this how you do the check. You got 2 all divided by, if I go divide, 2 divided by x. Now, this 2 is actually 2x to the power 0. This is x to the power 1. This is now regarded as a proper fraction, not an improper fraction. This is a proper fraction because the numerator is of a lower degree than the denominator, so there's no division. That's you stop there. This is the remainder. So this is your remainder. Again, it's taking me a long time explaining it, but it can be done in maybe 30 seconds, 1 minute, and you're done. As long as you follow the process without making any silly mistakes. Alright, so now let's write this out. So remember, now this is a proper fraction. So you stop dividing. That's what you need to remember. You stop dividing as soon as you reach a proper fraction. Okay, now let's write this out. So what is this now equal to? So from here, that was the question. It was given to you in that form. What did you do? You used long division, and then we got 2x plus 1 plus, you always add this quotient plus the remainder over the denominator, always. It's your quotient plus the remainder all over the original denominator or the divisor. How do you know if this is correct? In the exam, you do not take a chance here. You will substitute a value for x here. Substitute a value for x, any value you want to. Let's do it now. Right, let's do this now to make sure. Let's take a value like, don't substitute 3 because you're going to get an error on the calculator. 3 minus 3, you cannot divide. You can choose any number except 3. Okay, let's choose 5. I'm choosing 5, right, as an example. So you're going to work it out in the calculator for me. So if I put 5 here, 2 times 5 is 10, 10 plus 1 is 11. 5 minus, I can work this out without the calculator. It's simple. 2 times 5 is 10 plus 1 is 11. And this is 5. 5 minus 3 is 2. 2 divided by 2. 1. 1 plus 11. 12. Now I get 12 after long division. Do I get 12 before long division? That is the question. Now what do I do? Take that same 5. Put the fraction button, type this whole thing out here. This here. Put the 5 there. Who's fast? Give me the answer. As if you're sitting in the exam now. Do we get 12? So what does that mean? Peace of mind now, you understand? Peace of mind that you know what you are doing is 100% correct, and then you can move on. It means your long division is 100% now. Because I'm getting 12 here, I'm getting 12 here. I'm just using 5 as an example. You choose any value you want to. Whatever you get here must be what you get there. Right, so that's done. Let's move on. Now the integration. How do we integrate here? Simple. This is n4 integration, n4 integration. You can see this is 2x to the power 1. So that's going to be 2x to the power 1 plus 1. 2 over 2 plus integrate 1. X, be careful here now. This is not our n4 type now. Or similar to, but here this is a fraction. Okay, just like that was a fraction. This is a fraction, but this is an improper fraction. Okay, this is a fraction, but this is a proper fraction. So, this is in the form f prime x all divided by f of x. And you know that if the numerator is an exact derivative of the denominator? The answer is going to be learn absolute value of the denominator. Let's see. Let's check. Do I need to rearrange this in a way that will enable me to check it better? Let's take out the 2, multiplied by whatever number is here. So there's my 2 here. And now there's my 1 here. Alright. Now, here's my function of x, which is x minus 3. Is the numerator an exact derivative of the denominator? Yes. Okay, that means I go straight for inspection. That's going to be 2 times learn absolute value of the denominator. Let's see, and you're done. If you want to use U-substitution, I'm not going to, that's going to be simple. Yeah? You let u equal to x minus 3. And you come, it just takes you maybe about 3 steps longer, but it's fine as long as you understand what you're doing. Here, 2 and 2 cancel, you're done. So that was method number 1. That was method number 1. Now I'm going to do method number 2 just to make sure that it's up to you at the end of the day. Copy this down, let me do method number 2. Right, so let's deal with method number 2. So what happens if you used a U substitution? So when you have fractions, then we are used to letting u equal to the denominator. What happens if you actually did this? Right, so now, let me go let u equal to x minus 3. So if u is equal to x minus 3, what is the normal process that we do? We always find du over dx, and we always make dx the subject of the formula. So du over dx is just 1 minus 0, which is just 1. Clear with that? So now I can make dx, so therefore dx, if I cross multiply, dx is equal to du, or du is equal to dx, that means dx is equal to 1 times du. Same thing. You're clear with that? Now, we have our, let me just write it out here. So now we have u, and in place of dx we have du. And that's the only thing that we have. We've got a problem now. Because we do not have a substitution for x squared. Sorry, we do not have we have a substitution for x minus 3. Okay, which is u. We need a substitution for x squared. We need a substitution for x. Basically, we need to get x in terms of u here. Right, so all you do is now, you make x the subject of the formula, so that becomes u plus 3 is equal to x. Can you see that? Now, so what's going to happen here is, you've got 2x squared minus 5x minus 1. But what is x? X has been replaced with the letter, or with u plus 3, u plus 3. Now, this whole problem has been transformed from the variable x is now the variable u. So let's go and multiply this whole thing out. Okay, that's the part that takes long here for this method. We will have to remove the brackets here. So I'm not going to write it, let me do it here. So I got 2x squared minus 5x minus 1. So what am I doing? I'm replacing x with u plus 3. I'm going to do my working out here, so it's less work for me. Okay. Now, I need to square this. Remove the whole brackets there. So if I square 2 terms, binomial, I'm going to square the first term, so that's going to be u squared. Middle term will be 2 times term 1 times term 2. So that's going to be plus 6u. Last term will be 3 squared, which is 9. That's squaring. Right. Minus 5 times u, minus 5u. Minus 5 times 3, minus 15. And then I still got my minus 1. You clear with that? Now, let's remove these brackets. Sorry, that's u squared. So now 2 times u squared will be 2u squared, 2 times 6u, that will be 12u, and then 2 times 9, 18 minus 5u minus 15 minus 1. Nothing difficult, it just takes long to go and, keep on squaring and removing brackets. What do we have now? We got our 2u squared. What happens here? About 12u minus 5u, which is going to be positive 7u. Constants, I have an 18 minus 15, which is 3, minus 1, which is 2. Alright, if you want to verify this, then you substitute a value there, and make sure they are equal. Okay, now let's transfer this information here. So I got 2u squared plus 7u plus 2 all divided by u du. Now this is like an M4 type of problem where we need to separate them into fractions because they are not in standard form here. You cannot integrate the top and the bottom individually. Okay, you have to simplify first. So what do I mean? It's going to be 2u squared over u plus 7u over u plus 2 over u. Here's my du, integrating with respect to u. So this is now equal to 2u squared divided by u is just u. U and u will cancel here. I end up with 7 plus 2 times 1 over u. You know why I'm writing it down as 1 over u. You do not take u to the top. Now it's all simplified. It's in standard form, ready to integrate. Ready and ready. Each term must be ready. So this 2 over u must be written as 2 times 1 over u. Why? Because here the numerator is an exact derivative of the denominator. So now, integrate this, that will be 2u to the power 2 over 2 plus 7u, integrating with respect to u, that's going to be 7u, and this is going to be integrating 1 over u, that's going to be ln absolute value of u. Let's see, you're done. Don't forget to substitute back. What was u? Everything must be replaced with x minus 3. My u was, there's my u here. U was x minus 3. And this is fine. Full marks. Yeah, you integrate it. It doesn't look exactly like the first one. You know, I've shown you before. You can, if you want to, you remove all the brackets. It's all unnecessary. The fact is, you integrate it, and that's that. Let's move on to the next one. Right, 4.1.4. What do we have here? We got sine multiplied by sine, and the angles are different. So what you need to take note of here, the angles are not the same or are different. So if the angles are different, maybe the formula sheet, then you will go to page 1 of the formula sheet under trigonometry. Yeah. So page 1 has all the formulas under trigonometry. We need to use the formula for this one. Sine multiplied by sine. So that's going to be sine A times, where is it here? There's it. Sine A, sine B. Okay. So there's 1, 2, 3, there's 4 here. There's sine times cos, cos times sine, cos times cos, and sine times sine. So sine A, sine B will be half, and this will be cos of A minus B minus cos A plus B. This comes from your compound angle formulas. Now, this has nothing to do with integration. This is just trigonometry. So we need to use our trigonometric, our formula, and then rewrite it in a standard form and then integrate. So now let's check. We got sine of pi x. So a is pi x. And then you got sine of x over 5. So b is x over 5. So step number 1 is to substitute here. So let me this is the formula. You need to substitute. So this you copy it down. So you will write down the formula first and then substitute into the formula. Right, don't just go and write it down one time. Whoever's marking your paper needs to see that you know what you're doing. Okay, you didn't copy it from anywhere. You know you transferred this information from page number 1 of the formula sheets. There's it here, and now let's substitute. So I got my integration symbol there. It starts with half. That constant half, you write it in front of it. So there's my half. You can see that? Now, I got cos of a minus b. So that's going to be cos of pi x minus x over 5. A minus b. Pi x minus x over 5 minus, there's my minus there, cos of a plus b. So that's going to be pi x plus x over 5. Simplify that. Add it up. Now, you need to integrate that. The problem is there, you have pi x minus x over 5. It needs to be simplified. Because when you're integrating this, you're using the formula like how we did in N4. Okay, when you got just a straightforward, simple thing to integrate, if the coefficient of x is just a number here, so this is going to be k sine bx all over b. Let's see, this is what we need to do. But we got a problem there. Let's deal with the first problem. Pi x minus x over 5. If you want to find an LCD, you can. If you want to find an LCD here, it's going to be 5, so that will be 5 pi x minus x all divided by 5. But it doesn't really help you in any way if you find the LCD here. Right, because these two are unlike terms here. This is, you can subtract if you want. You can use your calculator. Nothing is stopping you from using your calculator, but let's look at a way that we're going to avoid using the calculator. So instead of doing this here, all I have to do is take out x as a common factor. If I take out x as a common factor, I'm left with pi minus 1 over 5. Can you see that? So what does that mean here? Here I have half the integral. I got cos, and then I have pi minus 1 over 5 x. Can you see what I did? It's multiplication. So the order doesn't matter. A times b is b times a. So there's this. There's my b now. The whole idea was to rewrite it in a form b times x. There's the coefficient of x that you want now. Can you see that? Minus cos. Take out x as a common factor there, so you're going to end up with pi plus 1 over 5 times x. So now it's a straightforward example. Let's integrate. So that's going to be 1 over 2. Integrating cos, there's it here. Cos of bx, that's going to be sine of pi minus 1 over 5 x all divided by pi minus 1 over 5. And whatever number this is, you divide it. Then we got minus integrate cos, that's going to be sine of pi plus 1 over 5x all divided by pi plus 1 over 5. There's no need for you to do anything more. This is, you've integrated, and that's what was required there. You don't need to go and use a calculator. So you can leave it as it is. It deserves full marks at this stage because there's nothing more to do. There's no point in working this out here because it doesn't make any difference to the final answer. It's not like you need to integrate again. But if you want to, then you can take your calculator and go pi minus 1 over 5, work out what this actual number is. You want to work it out? It's your choice. Right, we've got one more for this question. 4.1.3, we've got 4.1.4. 4.1.5 is our next example. So it's a fraction. It stands as a fraction, but clearly now you can see that if you differentiate x squared, you don't get ln x. If you differentiate ln x, you don't get 1 over x squared. So this is not an exact derivative problem. First thing you always check for is, can I use U-substitution? Or trig substitution. Will trig substitution work? No. Right, so what do we do here? You got ln x divided by x squared. What you can do is you can take x to the top, so it becomes ln x multiplied by x to the power minus 2. So this is multiplication, but there's no exact derivatives. So therefore, this is integration by parts. Okay. This is integration by parts. Integration by parts, not so much in N5. But the first thing that you do and the easiest thing that you do in N6 under integration. Right, so it comes out a lot in N6 in all a lot of applications and stuff. You'll find integration by parts. But for now, it's just a simple thing for you to do. Alright, so what do? You know, if you know that this is integration by parts, now you go to your priority lists. And what is your priority list for f of x? So remember, you go to your priority list. And then you choose f of x. The priority list is for choosing f of x. Okay. One of these two will be called f of x. One of them. Okay. Not just any one of them. You have to follow the order of the priority list. So, number one is inverse trig function. Do you see inverse sine, inverse cos? Obviously, you don't see that yet. Number two is your log functions, logs or natural logs. Do you see natural log? Yes, this is ln x, the base is e, it's called natural log. So, f of x has to be ln x. By the way, what number is this one? This is number 3 on the priority list. So, let me just refresh your memory for those of you unclear about this. This is number 2 on the priority list. And this is number 3 on the priority list. So, priority list starts with 1, 2, 3, 4, 5. Whichever one is higher up must be chosen as f of x. Okay. So 2 comes before number 3, so that is why this is chosen as f of x. So once I got my f of x is ln x, I know f prime x, the derivative of ln x is 1 over x. Now, what about this x to the power minus 2? X to the power minus 2 is called g prime x. So my g prime x is x to the power minus 2. It means that this is a first derivative. This is an answer to something that has already been differentiated. That's what it means, g prime. But the formula, let me write down the formula first. The formula is f of x times g of x minus the integral of g of x times f prime x dx. So what does this formula require? It requires f of x. Do you have f of x? Yes, you have, that's your limits. F prime x, which you worked out after finding f of x. You worked out f prime x, you know. You got your substitution here for f prime x. The only thing that's missing is g of x. Okay, so this is not g of x, it's always g prime x. So in order to get g of x, I need to find out what happened before this was differentiated. Right, so in other words, I need to integrate in order to get what was this here. So now, to get g of x, I'm going to integrate x to the power minus 2 with respect to x. When I integrate x to the power minus 2 plus 1 is minus 1 over minus 1, which is the same as minus x to the power minus 1, which is the same as minus 1 over x simplified. Are you clear with that? Okay, now let's do the substitution. My f of x here is ln x, and g of x, there's my g of x there, which is minus 1 over x. Remember, g of x appears twice in the formula. Whatever you do here, you substitute the same thing this side here. So this is minus 1 over x. F prime x, the derivative of ln x is 1 over x also. This was an easy one. And in fact, the integration by parts is not difficult. Okay. It's actually even shorter than working on some of the other examples. The main thing is you must know your priority list. Priority list is not given to you. You have to memorize that. Let's simplify here. So that's going to be minus 1 over x times ln x. It doesn't really matter. It's multiplication. But here now, be careful. You've got a negative times the negative there, which is a positive. Fraction times a fraction without a calculator. 1 times 1 is 1. X times x, x squared. Simplify. Take x to the top, and it becomes x to the power minus 2. And now you can integrate. Now you're just rewriting it in standard form. So this is equal to minus 1 over x times ln x. Now I need to integrate x to the power minus 2. So minus 2 plus 1 is going to be minus 1 all over minus 1 plus c, you're done. That's your format. That's minus 1 over x ln x. Integration by parts, very important. Positive divided by negative is a negative. X to the power minus 1 is 1 over x. So that was our integration by parts. Not so significant in N5. You will not fail if you don't know integrate, but guaranteed in N6, if you don't know this, you will be repeating. Alright, so let's deal with the last part of part 2 of this session, partial fractions. So let's rewrite this as a fraction x plus 2 all over x minus 1 all squared. Now, okay, this question stated that you must use partial fractions. I didn't write it down, okay. It stated that you have to use partial fractions. It is not the only way to work out this problem. Right, but if it states partial fractions in the exam, then you have to use partial fractions. Now, first of all, how do you know that you need to use partial fractions? The numerator must be of a lower degree than the denominator. So what does that mean? The highest power of x in the top is 1. In the bottom, if you remove the brackets in the bottom, After you remove the brackets, the highest power will be, remember it's going to be x squared. So this is a 2, that's a 1, it's okay. As long as you have a proper fraction, then you can apply partial fractions. Now, that's the first thing to check for. Now, how many constants are you going to have? How many fractions are you going to have, in other words? There's going to be 2 fractions here because the highest power in the bottom is 2. You can say that. So now, that's going to be a all over x minus 1. You can start with 2 or 1 if you want, doesn't make a difference. Plus b all over x minus 1 squared. Okay, so we are rewriting it as 2 fractions. Now, what do we do next? We are going to multiply by x minus 1 all squared here, here, and there. That's what's going to happen next. So, I'm multiplying by x minus 1 squared there, x minus 1 all squared there, x minus 1 all squared there. Okay, it's just a method, a simple thing to do, and that will always cancel. I got x plus 2. All the denominators must be out completely. If something does not cancel in the bottom, you made a mistake. So that's how you check. X minus 1 must cancel there, so I'm left with a times x minus 1. That and that will cancel, so I end up with just b times 1, because anything divided by itself is just a 1. You can see that? Now, substitute values for x, or you can use the method of equating coefficients. But substituting values is much faster. So what value is the best value to substitute into this? What's the best value to get me to a solution? 1, exactly. Why? Because 1 minus 1 will be 0. And 0 times anything is 0, and then I'll work out b. So now I will let x equal to 1. So remember both sides. So on the left hand side, 1 plus 2, that's 3. 1 minus 1, 0. 0 times a, 0. The whole idea of substituting 1 was to get that 0. Plus b. So in a few seconds, we already got the value of b. So therefore, b is equal to 3. Now, you do not have a value that's going to get you to the solution in a few seconds. So you have to substitute any other value you feel like. So let x equal to, now, you substitute anything you feel like, except, obviously, don't go and substitute 1 again. You're wasting your time. Any other value. Choose an easy number like 0. 0 is easy to substitute. Okay, you don't need a calculator for 0. So let x equal to 0. So what does that mean now? On the left hand side, I got 0 plus 2, which is 2. On the right hand side, I got 0 minus 1, which is minus 1. Minus 1 times a is minus a, plus 1 times b there is just b. I already know that b is equal to 3. That means I can replace b with 3. So 2 is equal to minus a plus 3. Solve for a. If I take minus a to the left hand side, that means a, positive a now, is equal to 3 minus 2. I'm taking a to the left, 2 to the right. So 3 minus 2 is 1. You all got that? It depends now. It depends now. I said a over x minus 1 to the power 1. You could have started with a over x minus 1 to the power 2 plus b all over x minus 1 to the power 1. So our a and b will be different at this stage, but now it will all be the same. As soon as I do the substitution, it will all be the same. So therefore, what do we have here? A all over x minus 1. 1 all over x minus 1. And then I have b all over x minus 1 all squared. So that's going to be 3 all divided by x minus 1 all squared. Now, everybody's answer must be equal. If it's not equal, it's wrong. Everyone should have 1 over x minus 1. Everyone should have 3 over x minus 1 to the power 2, no matter what method you use now. Whether you use the equating coefficients method or this one that I just did on the board. Let's check now. What do we have here? We got type division, f prime x all divided by f of x. This is type, it appears to be division, but it's not a division type example. This is a multiplication type example, not division, be careful. Right, so this is not in standard form. So I cannot go, I'm not going to integrate anything at the moment until I get this into standard form. So there's my 1 times 3, which is 3. Take this to the top, and it becomes x minus 1 to the power minus 2. Now you can integrate it. I'm going to do it by inspection because I noticed that this is just a 1 there, this is just a 1 there. Whenever it's a positive 1, it's an easy integration problem. So here, the numerator is an exact derivative of the denominator, which we have done. I've explained it to you before. It's going to be ln absolute value of the denominator. Right. Plus here, f of x, f prime x. You got the power minus 2. So I'm doing this by inspection. Minus 2 plus 1 is minus 1. Or minus 1. Plus c. The derivative of 1x is 1. I don't need to do any tricks with the fractions. You understand that? Now we're done. Let me just simplify. That's going to be ln of x minus 1. Positive divided by a negative is a negative 3. Let me take this to the bottom and make it positive. So that's x minus 1 plus c. Your easy 5 marks. There is nothing difficult about what happened here. Absolute nothing. This is an easy 5 marks. Right, so we continue next time for the other parts of this paper.